Good morning, everyone, and thank you for joining again. This is video for day number 3, and today we are going to talk about handling outliers. So, in the previous video, you saw how to clean data, how to fill missing data, how to drop uh, rows of missing data, how to split the dataset into two different datasets, one for categorical values and one for numerical values. And today, let's talk about outliers. So, what's an outlier? Outlier is a data point which either too high or too low from the median or from the average, let's say, to make it simple. And how can we handle it? So let's see. So we are going to import the matplotlib library and the seaborn. Then we are going to use this library to plot one of the fields, which is the RAM field. And I think it's better to explain it with the drawing. So basically, we have the median here on this line. Then we have the 75 quartile and the 25 quartile. So these are the numerical values where most of the data points are. And these are extremes. However, in the drawing, we can see some data points which are really far from the box. These are outliers. In the real world, outliers can be typing errors or they can be real. So it's up to you to decide whether they should be dropped or not. Let's do the same with the mobile weight. You see, most of the phones they weight too low, below 200 grams, but some of them are too high, probably typing errors. What about if we plot all the numerical values at the same time? So let's see. Here we are seeing all the numerical values and the outliers. So for the weight, for the RAM, and for the height of the phone. Okay, but as you can see, the range of the values is different, no? So you have one here on the left, which is between 1000 and 2000, but here on the right, you see which are some values are very close to zero. So we need to standardize those values. How do we do it? With the scikit-learn library and with the standard scalar. What are we going to do? So this library, what we are going to do is uh, standardize the data features by removing the mean and scaling to unit variance. That looks complex, but let's see how does it work. And let's see it on the real data. Basically, what it does, it converts the numerical values to a standardized version of the values so that they are close to each other in a data range. Let's see this in the describe. If you see, for every one of the fields, the the standard deviation is very close to 1 and the mean is very close to 0. But how does it work in real life? So we need to see it in a plot. Let's see it here with the subplot function. So what we did with the standardized function in the previous steps is to make all the range like you see in the picture. So they are relevant to each other. Let's see it. Say it that way. Does it make sense? As you see, all the median is 0. The range it makes more sense than the previous graphic because they are close to each other, and now we can clearly see the outliers. You see the outliers for megapixels, for the weight, for the RAM, and for the height as well. Okay, there is also another function called robust scalar to make the same thing, but using different mathematics behind it. Let's see it. So we standardize the data using a different scalar function from the scikit library. Let's describe it, and we can see it here. The standard deviation is close to 0.5 and the mean deviation is close to 0. Now let's plot it again, and you can see the outliers. Now we need to remove the data that we are not interested. How do we do it? So we need to calculate the interquartile range. So it's also called mid-spread. It's a measure of statistical dispersion, which is equal to the difference between the 75 percentile and the 25 percentile. Basically, it shows the data points which are in the middle of the data set. Let's say like that. Okay, does it make sense? Let's see it. So now we have the interquartile range for every numerical field. Now we have to remove data. How do we remove data? So we will add 50% to the interquartile range, and everything outside that we will remove it. That's basically the mathematics behind it. Okay? And after we remove it, we have less rows to process, 1971, and I think in the beginning we have 2002 or something like that. Makes sense? Now we can plot it again, and there are not outliers anymore. Okay? So here is the video for day number 3. I hope you find this video informative. I'm not focusing on the mathematics or statistics. I'm trying to explain it for developers. These training tutorials are not for statisticians. And see you in the next video. Thank you.